Welcome to Curie Electronics. So this is the second part of Iprc 2016 Technician B Electronics question paper. So first part we have completed 30 questions. So in this part we are going to solve question number 31 to 60. So with this we are going to complete 3 question papers of Iprc. That is 2016 there were 2 exams and 2018 there was 1 exam. So total with this video we are going to complete 3 question papers. So if you like the video, please share with your friends and don't forget to hit the like button. So let's start solving the questions. Question number 31. What type of circuit is shown below? If we look here, this is a resistor circuit, resistive network. So here resistors are in parallel, here also parallel, but this 10 ohm, all these 3 are in series. So it is a series parallel combination circuit. Series parallel combination circuit. Option B is the right answer. An example for semiconductor. This copper is a metal, aluminum is also a metal, mica is insulator or we use it for dielectric also. So the answer is germanium. And one more material we have is the silicon. So how many electrons are there? In the outermost shell of this semiconductor material? That is 14 valence electrons. Question number 33. PNP transistor has the following arrangement. So PNP transistor. How do you draw a PNP transistor? No. The arrow should come in. So this is a PNP transistor. We have base, collector and emitter. So we can show it like this also. That is emitter, base, collector. Emitter, base, collector. PNP. Okay, now the base is of N type. Which option match for this? Option B, P type emitter, N type base and P type collector. So option B is the right answer. Correct, because emitter, base, collector is a PNP, means base is the N type. Other emitter and collector are P type semiconductor material. Question number 34. Resistance of an ideal diode resistance during reverse biasing. So we are considering an ideal diode. If we connect a potential, that is cathode of the diode, not cathode, that is the anode. Anode, cathode. So we are applying positive potential to cathode and positive potential to anode and negative potential to cathode. This is the forward biasing of diode. An ideal diode resistance is equal to 0 when it is forward biased. But when it is reverse biased, that means anode we will connect to negative supply, positive will connect to cathode. So when you connect like this, this is the reverse biasing of the diode. For an ideal diode, when it is reverse bias, it will have an infinite resistance. But practically it is very high, but ideally infinite. Question number 35. In common CB means common base configuration of transistor, the output impedance is, we have a transistor, the base is common for input as well as output. Here between emitter and base we are applying the input, base and collector we are taking the output. Common base configuration. What is the output impedance? For a common base configuration, output impedance is high. What about input impedance? Input impedance. Impedance means, I'll write it, impedance equal to very low. Also, what is the gain of a common base configuration? That is alpha equal to delta IC upon IB. Delta, not IB, IE. So this value is always similar to 0.9899, like that. Okay, so let's move to the next question. Question number 36. A ripple factor for full wave rectifier. What is the ripple factor of full wave rectifier? For full wave rectifier, it is 0.48. And this is for half wave rectifier. Half wave rectifier. Half wave rectifier. And this 1.11 is known as the form factor value for AC. Form factor. Question number 37. Light year is a unit of, see, from what is the distance between Earth and Moon, from here to from Earth to one of the stars, from Sun, from Earth to Sun, what is the distance? This all measured using light year. So that is, light year means it is a unit of distance. It's a unit of distance. I think 1 light year. Okay, doubt a little bit. Which of the following is an essential component of electromechanical relay? Electromechanical relay means there is a coil or one electromagnet is there. There is a coil. This electromagnet will get magnetized and pull the switches. That is contacts, or switches or contacts. Electromagnet is an essential part of electromechanical relays. Question number 39. Cascading two amplifiers will result in. When we cascade two amplifiers, what happens? Their gain will increase, but the bandwidth decreases. Bandwidth decreases. Increase in overall gain and reduction in overall bandwidth. Question number 40. What is the relationship between current and voltage in a circuit consisting of a capacitor in series with resistor? So we have a resistor and a capacitor. It is connected to an alternating supply or signal. See here, what is going to happen here? The capacitor, it is going to across the capacitor. If you see, current will lead, voltage will lag. But across the resistor, both are in phase. Both I and current. Across the resistor, voltage and current are going to be in phase. So the answer is option D. There is no phase difference across the resistor between the current and voltage. Question number 41. The most popular IC used in timing circuit, that is, all of us know it is 555 timer. This 555 is the answer. So it is known as the timer IC. So what is this 741? It's an op amp. How many op amps are there in this? Only one op amp. What is LM317? It is a voltage regulator. Voltage regulator. It's a voltage regulator. It can regulate from, I think it is from 1.2 volt to around 1.2 volt to around 37 volt. Variable voltage regulator. This 7400, it's a TTL gate, and it is a NAND gate. 7400 is the NAND gate. Question number 42. An op-amp circuit that has its output tied directly to the inverting input signal is called. So let's try to draw the diagram. An op-amp circuit. For an op-amp, we have what we have? Non-inverting terminal and inverting terminal. This is the output. So the output is tied to inverting terminal. So this circuit is actually a voltage follower. So this is a voltage follower. The answer is option B is the right answer. Question number 43. What specification of an operational amplifier give how fast the output voltage can change? It is the slew rate. Okay, slew rate. See, when we want to use op-amp for high frequency, with the input changing, whether the slew rate allows the op-amp output to change. That is what known as slew rate. And unit of slew rate is usually volt per microsecond. How long? It's like how long it will take the input signal or the output to change. Slew rate. Okay, how fast? That means it's a time related. Volt per microsecond is the unit. Question number 44. A stable multi-vibrator is it is a square wave clock. The number system with base 16 is called. It is the hexadecimal number system. Now binary means what? We will have 0 and 1. Now, what about octal? Octal is for 8, 0 to 7, and decimal 0 to 9. So question number 46. A triac is dash switch. See, a triac we use it in AC circuits to control it. A triac will have two terminals, MT1, MT2, then it will have a gate. This gate is to control the triac. So it's a bidirectional, okay? Triac is a bidirectional switch. It's a bidirectional switch, control switch. Question number 47. A circuit that operates in such a way that its output is high when all inputs are high. So it is going to be the AND gate. So for an AND gate, output is going to be 1 whenever all inputs are high, or we can say it as 1. A BCD code has always dash bits per number. See, in BCD, if you want to represent 5 is a number, we want to represent it in BCD, what is there? We can write it as 0, 1, 0, 1. This is 5. If you want to represent a 7, then it is 0, 1, 1, 1. So always 4 bits. BCD, 4 bits are there per number. If it is 55, then again once more you have to add 4 more bits. 1 or 1. So it's a OR gate operation. Okay. Sorry, OR gate operation. So what do you get output? 1. So what is the output here? Y equal to a 1 or 1, which is equal to 1. For an OR gate, if at least one input is high, we will get output as output high. So we will get answer is option A is the right answer. Question number 50. An acceptable voltage range of a logic 0 for TTL. So it should be 0 should start from 0 volt to 0.8 volt. So the answer is option A is the right answer. That is from 0 to 0.8 volt. See, this 3.5 volt to 5 volt we can take it as an acceptable logic 1. This is logic 1. Question number 51. A shift register in which the output of the last flip-flop is connected to the input of the first flip-flop. Okay. So that means we have a shift registers. I'll just draw 2 shift registers. There can be 3 or more. So data is a D flip-flops. Q, and this is D. D, then we have one more output Q. We'll apply clock to it. Now what is there? These are shift registers. Whatever D input, whatever here input give, that will get shifted towards right or left. Right. This as per here is right. Now what we do from the output, that is Q. Q will be connected to the input. This is known as the ring counter. Okay. This is known as the ring counter. Ring counter will have n states. If now how many here 2 flip-flops are, so 2 states are there. Like that, if you have 3 flip-flops, it will have 3 states. N states. N states. I am trying to finish one question in 1 minute, so I'm not explaining more. Okay. N states. So here we have 2 states. N equal to number of flip-flops. Say for a ring counter, if we use 3 flip-flops, it has got 3 states. In the logic circuit shown below, the output F equal to. Now, now let us assume that first we will give 0 here. Once we give 0, it is a XOR gate. So for a XOR gate, when inputs are same, output is going to be 0. Now again, both the inputs are same. Again you will get 0. Again both the inputs are same, output is going to be 0. Now let us give 1. What happens 1? If we give 1, both inputs are 0. So both inputs are same, that is 1. Output equal to 0. Output equal to 0. Now for the second OR gate, one input is 0 and other input is 1. So we will get 1. But for the third OR gate, both the inputs are 1. See, both the inputs are 1. So again, for an OR gate, whenever both inputs are 0, both the inputs are same, we will get output 0. So here if you see here, x means what? X can take either 0 or 1 only. So whatever the value we give to this input, we are getting output 0. So the answer is option A is the answer. Question number 53. Data storage in a memory is termed as, it is a writing process. See, when we say we are storing a memory, storing the data, or we are storing in a device, it means it's writing to the device. Question number 54. How many bits are there in a byte? All of us knows 8 bit makes 1 byte. These 4 bits are known as 1 nibble. Question number 55. It converts a non-electrical physical quantity to an electrical quantity. What it is? It's a transducer. Transducer which converts one electrical quantity to non-electrical quantity. It can be electrical quantity to non-electrical or electrical quantity to non-electrical quantity to electrical. So it's a transducer. Example, mic, the different sensors. Inverter. What is inverter? Inverter is a circuit or a device which converts DC to AC. Logic inverter also there. Compiler means see, whatever code we write in C language, we have to compile it to compile. Using a compiler, we will convert into a machine language code. That is high level language to machine language to machine code. That's a compiler. High level language to machine code. Find the sum of binary numbers 1010 and 0011. So what we have to do? We have to just write it. That is 1010 0011. So 0 plus 1 1, 1 plus 0 1 plus 1 1 0. So 0 1 carry, 1 comes here. So it is 1101. Or else what you do? This is, we know 1010 equal to 10. This is 3. So 13 we will get. Now this is 3. Okay, 0 3. So 13. 13. How do you write it? 13. 13. If you want to write 4 bits, we need 8 plus 4, 12, 1, 13 to the base 2. Question number 57. Files in an email communication are sent through attachment. We always write, please find the attachment. Whenever you send a Gmail or Yahoo mail, there's an option to attach the files which we have to send. So it is attachment. Question number 58. What happens in the resistance of copper wire when its temperature is raised? This one for metals. When temperature increases, what happens? The resistance also increases. For semiconductors, generally semiconductors, when temperature increases, resistance decreases. So what is the question? What happens in the resistance of copper wire when temperature is raised? Temperature raised, resistance increases. Question number 59. The purpose of cells connected in parallel is to, when we connect batteries or cells in parallel, it is to increase the current carrying capacity. Ampere hour, we will say no, AH of a battery, ampere hour, to increase the ampere hour, that is increase the current capacity. The system program used to translate directly an assembly language to machine language. That is the assembler. Compiler usually from C to machine code. machine code. Text editor. Text editors, what is our this one? MS Word, Notepad. These are the text editors. A debugger. Debugger we use when we program 8051 microcontroller and all, we will use debugger. So with this, we have completed the second part also. So I hope you understood how to solve these questions. If you have any doubt, please ask in the comment section or you could message me. And thanks for watching.